Solving systems with substitution. The first method we used to solve systems was by graphing. The graph shows all the solutions for both equations. Remember what you're looking for, a point that is a solution to both equations. Graphing is one way to get that. Where they intersect, that's a point that if you plug it into the equations will make both equations true. It's a solution to both. There are algebraic ways to find that too, and the first one we're going to look at is substitution. When we substitute, the first thing we do is solve for a variable. Get a variable by itself. Notice if you look at this question that we have a variable by itself. Y is all by itself. If you don't have a variable by itself, that's the first thing you have to do, and that will happen later in the assignment. For these first questions, though, it's set up for you. You've already got a variable by itself. So our second step is to substitute into the other equation and solve. Our other equation is 7x plus 3 times y. This is y. Well, I know what y equals because I'm looking for the same x and y in both equations. Y is equal to 5x minus 25. These two are the same thing. Y is equal to that. That means I could go up in the other equation and substitute in for y 5x minus 25. So our equation becomes 7x plus 3y, I replaced y with 5x minus 25, equals 13. That's this top equation. Now what we have is an equation with one variable. We can solve that. 7x plus, I'm going to distribute and take the 3 to both. 3 times 5 is 15, so that's 15x. 3 times 25 is 75. Notice I bring down that minus. Equals 13. Always simplify whenever possible. 7x plus 15x is 22x minus 75 equals 13. Get the x by itself. The first step is to add 75 to both sides. The last thing we're going to do is get rid of that coefficient. That's the last thing when we solve an equation. This is 22x equals 88. We'll divide both sides by 22, and I see that x equals 4. Now I only have half of the ordered pair. I know that where the two lines intersect, x would be 4. So what I have to do is substitute again. You can use either equation, but one of them is generally easier than the other. If it's me, I pick the one to solve for. I know that y is 5x minus 25. That means I can find y by replacing x with 4, because I know that x is 4. Minus 25, y would equal 20 minus 25, so y would be negative 5. Now you heard me say, it does not matter which equation you use. You'll get the same exact answer if you plug it in this top equation. You'll just have a little more solving due is all. Our answer is always an ordered pair in alphabetical order. 4, negative 5. Enter that in your answer box and you're good to go. In the last question, y was by itself. You must have a variable by itself, but it can be either variable, any variable. X works just fine. X is by itself. I know that x is the same thing as 3y plus 2. That means I can replace x right here with 3y plus 2. You need parentheses. 5 times x. X is equal to 3y plus 2 plus 4y equals 56. Distribute the negative 5, negative 15y minus 10 plus 4y equals 56. Always simplify whenever possible. Combine your like terms. Negative 15y and positive 4y is a negative 11y minus 10 equals 56. Get rid of the coefficient last. Get the variable by itself, the y. We're going to add 10 to both sides. We get negative 11y equals 66. Divide both sides by negative 11, and y will equal negative 6. Now, just like we did in the last question, I need an x and a y. Here I only have the y. I'm going to take this value and plug it in one of the equations. This one will work fine, but you have more solving to do. I would probably use the top one. X equals 3y plus 2. Now replace the y with negative 6. 3 times negative 6 plus 2. X equals negative 18 plus 2. That means x equals negative 16. Our answer, as always, is an ordered pair in alphabetical order. X, then y. X is negative 16, and y is negative 6. Question 3. I'm not going to do every question on the assignment, but most of them. I think I did 10 out of 12. 12 is all you have here. This does take a little bit of time, but hang in there. We need to practice. X is by itself, and x equals negative 3y minus 1. I'm going to replace x in the other equation with negative 3y minus 1. I'm going to substitute something equals in x place. 3 times negative 3y minus 1 minus 4y equals negative 16. Distribute, multiply 3 by both, negative 9y minus 3 minus 4y equals negative 16. Combine like terms, negative 9y and negative 4y make negative 13y minus 3 equals negative 16. Now we can add 3 to both sides. Negative 13y equals negative 13. Divide by negative 13 to get y by itself, and y equals 1. X is negative 3 times y minus 1. I'm going to use this equation again. Either one works though. X will equal negative 3, replace y with 1, because y equals 1, minus 1. That's negative 3 minus 1, which is negative 4. Our answer is an ordered pair in alphabetical order. That's negative 4, comma 1. Question 4. Get the variable by itself. Y is by itself. 7x minus 6 times y, negative 4x plus 17, equals 53. So what I did is I replaced y right here with what y was equal to, negative 4x plus 17. Distribute. Now this is tricky. Be careful. This is a negative 6. When you distribute, you've got to change both signs. Negative 6 times negative 4 is positive 24x. Negative 6 times positive 17 is 60 plus 42. That would be negative 102. 6 times 10 and 6 times 7 added together equals 53. Combine like terms, simplify. 31x minus 102 equals 53. Get the variable by itself, get rid of the coefficient last, add 102 to both sides. 31x equals 155. Now we can divide both sides by 31. 155 divided by 31 is 5. So x equals 5. We need to take that and plug it in one of the equations. Either one is fine. This one's going to be the easier one. Y equals negative 4x plus 17. Y will equal negative 4 times 5 plus 17. That's negative 20 plus 17, and negative 20 plus 17 is negative 3. Our answer is an ordered pair in alphabetical order. X is 5 and y is negative 3. Our next example is question 6. Notice again that we have a variable by itself. That's the first thing we need. Y is equal to 1x plus 8, or just x plus 8. And I'm going to replace y in the other equation with x plus 8. So we get 2x minus 2. You need parentheses because this is y, is going to become more than one thing. X plus 8 equals negative 3. Now we're going to distribute. We're going to distribute negative 2 through the parentheses. Negative 2 times x, negative 2 times 8. Don't forget the negative when there's a minus in front of parentheses. 2x, negative 2 times x is negative 2x, and negative 2 times positive 8 is negative 16, equals negative 3. Simplify, combine like terms. Uh-oh, look what happens here. 2x minus 2x is 0. So we get negative 16 equals negative 3. Uh-oh, something's wrong here. Reminder that there were 3 possibilities when you solved a system of equations. Think of the graphing. The 2 lines could intersect at one point. The 2 lines could be parallel, meaning they would never share a solution. There would be no solution to the system. Or you could graph a line, and the second line could be the same exact line, and they share every ordered pair, meaning there are an infinite number of solutions. This is a false statement, which is a clue that this is what's going on. These 2 lines are actually parallel, and they don't intersect. Look at the equation, y equals 1x plus 8. And look at our other equation, 2x minus 2y equals negative 3. If we move the 2x to the other side, minus 2x, negative 2y equals negative 2x minus 3, and we divide by negative 2, this equation, which I'll put in blue, becomes y equals x minus 3 halves. Notice the slope is 1. Notice the slope of the other equation is 1. These 2 equations have the same slope, meaning they're parallel. And the intercepts are different, 8 and negative 3 halves, so they don't intersect anywhere. They're parallel. There is no solution to this system. If you solve, the variables drop out, and you get a false statement, that's your clue that this is a no solution. This is the correct answer, not that one. Question 7. Note again, we have a variable by itself. X is 2y plus 3. I'm going to go in the other equation and replace x with 2y plus 3. 7, there's my x. It becomes 2y plus 3 plus 6y equals negative 79. 14y plus 21 plus 6y equals negative 79. Combine like terms, 14y and 6y make 20y plus 21 equals negative 79. Get the y by itself. The coefficient is the last thing we get rid of. Minus 21 minus 21. So we have 20y equals negative 100. Divide both sides by 20 to get y by itself, and y would equal negative 5. To find our other answer, we need to plug that negative 5 in one of these 2 equations. Either one works. The one that's solved for is generally a little bit easier. X equals 2y plus 3. x equals 2, and replace y with -5 plus 3. That means x is -10 plus 3, and -10 plus 3 is -7. Our answer is an ordered pair in alphabetical order, -7, -5. Question 8. Again, a variable is by itself. We're ready to go. Y is -8x plus 7. I'm going to replace y in the other equation with -8x plus 7. 16x plus 2 times y. This is my y, and I know that it's -8x plus 7 equals 14. And I'm going to distribute +2 through the parentheses. 16x plus -16x plus 2 times 7 is 14 equals 14. Simplify. Right here, 16x plus -16x is 0. That leaves us with 14 equals 14. This is a true statement, which again is a clue to the solution. Remember graphing. There were 3 possibilities. The 2 lines you graph could intersect in a single point, in which case there's one answer. The 2 lines you graph could end up being parallel. They don't share any solutions. There would be no ordered pair that worked in both equations. There'd be no solution. Or you could graph the line and graph the second line, and the 2 equations overlap. They share every ordered pair. There'd be infinite solutions. That's what's going on right here. This true statement is a clue that there are infinite solutions. And again, if we take our first equation, -8x plus 7, and our second equation, 16x plus 2y equals 14, and compare them, let's solve for y. Move the 16x over, subtract 16x from both sides. We can't combine these two. They're not like terms. That leaves us with 2y equals -16x plus 14. Divide by 2, and we can see that this equation right here becomes y equals -8x plus 7. In other words, the 2 equations are the same. These 2 equations are really the same equation. They don't look the same, but they are. They overlap each other and share every ordered pair. There are an infinite number of solutions to this system of equations. The next example is question 9, and we finally get a system where there's not a variable by itself. This question isn't any harder than the others, and the reason is they've made it fairly easy to get a variable by itself. You see how this y has no coefficient? That means I could get y by itself if I just move the 9x to the other side. So pick the variable without a coefficient. It's much easier to solve for. Let's move that 9x. We'll subtract 9x from both sides, and this equation becomes y equals -9x plus 34. Can't combine the 9x and the 34. Now we're not going to use that one. We're going to use this one and this one to solve the system. I've got a variable by itself. I'm going to go in my second equation, -6x plus 6 times y. Here's my y, -9x plus 34 equals -36. We'll distribute. Take the 6 to both, -6x plus -54x plus 6 times 34 is 6 times 30, 180, plus 6 times 4 is 24, that's 204, equals -36. We'll combine like terms. Negative 6x and negative 54 make negative 60. Plus 204 equals negative 36. Eliminate the coefficient last. Let's move that 204 to the other side. Negative 60x equals negative 240. Divide by negative 60, and x equals positive 4. Notice it was a negative divided by a negative, which made it positive. We need to plug that in one of these equations. Let's use this one. X is by itself. It's going to be easier to work with. Y is equal to negative 9x, and we'll replace x with 4 plus 34. Y equals negative 36 plus 34. Y then equals negative 2. Our answer, as always, is an ordered pair in alphabetical order. That's 4, negative 2. Our last question is like the previous question in that we don't have a variable by itself. You need to get a variable by itself in order to substitute. Just like the last question, you want to choose the one that has a coefficient of 1, that there's nothing in front of the variable. That x is going to be the easiest thing to solve for because all I need to do is move the 2y to the other side. Add 2y to both sides. You can't combine 7 and 2y. Let's put the 2y in front. This equation becomes x equals 2y plus 7. Now we're not going to use that one. We're going to use this one and the top equation. The top equation now becomes 5 times x. This is my x, and I know what x is. It's the same thing as 2y plus 7. 2y plus 7 minus 4y equals 17. Let's distribute. 5 times 2y is 10y. 5 times 7 is 35. Combine like terms. 10y and negative 4y make 6y plus 35 equals 17. Take a 35 off each side. 6y equals 17 minus 35 is negative 18. Now we can divide both sides by 6, and y equals negative 3. Let's use this equation to substitute. X is equal to 2 times y, which is negative 3, plus 7. That's negative 6 plus 7. X then equals 1. Our ordered pair in alphabetical order is 1, negative 3. The most common mistake students make with systems of equations is sign errors. You've really got to learn to be careful with your work. Watch out for the double negatives. Remember that you might need to distribute a minus. Check everything with your calculator. With practice, these type of questions will get easier.